Howdy, my name is Noah Kim, and the insect I will be discussing is the Dactylopius coccus, more commonly known as the cochineal scale.
Howdy, my name is Allyrose and the insect I will be discussing is the Bombyx mori, more commonly known as the silk moth.
Today, to begin, I'll be going over the basic biology of the cochineal scale. This insect belongs to the family of Dactylopidae in the order of Hemiptera. Like many insects, the cochineal scale starts as an egg laid by their mothers. Females will lay their eggs between their secreted wax and can produce up to 500 to 600 eggs in their 2-month lifetime. They usually lay their eggs in May and they will hatch in either late July or late June or early July. Once they hatch, if they are female, they'll crawl to the top of a plant where they will allow the wind to help them disperse. Once they are dispersed, they'll find a cactus and find a place to settle. If they are male, they will stay on the plant where they hatched and settle there. After about 3 weeks, they will have developed into adults. Males have a cocoon-like state called a pupa. They do not have a true pupal state, but this allows them to develop into winged adult forms. And once they get to that stage, they will then begin searching for females to mate with. Once they find a female, they will approach them by vibrating their wings. If a female is receptive, they will mate by exchanging sperm through specialized structure on their genitals. The females then fertilize and will eventually lay eggs while the male will continue to spread its sperm. After that brief deep dive, I'll now be going over the significance of the cochineal scale in human society. Cochineal scales are mainly used by indigenous people in the Americas as a fabric dye. Many civilizations like the Mayans and Aztecs used them as early as the 2nd century BC. The dye produced by the scale is called carmine, which has a red to purplish hue to it. These dyes would make their way over to the Old World around the 16th century following the invasion of the Americas by the Spanish. These scales would then be traded worldwide and have many different applications due to their vibrant colors. Not only were their clothing dyed, but they would be used as food coloring, paints, medicines, and even other cosmetics like lipsticks. Throughout Europe, carmine would become the color known as power by English soldiers. Even today, the dye is being used by many household items, including M&M, Skittles, lipsticks, eyeshadows, and many other common beverages or snacks. This wide variety of applications solidifies the cochineal scale as one of the most important insects of all history.
To start, I will be discussing the genetic makeup of the Bombyx mori, commonly known as the silk moth. The silk moth belongs to the Bombycidae family in the Lepidoptera order. You can spot a silk moth by its unique characteristics, these being that they are medium to large moths with hairy bodies along with feathery antennas. Something unique about the female silk moth is that depending on the species, their antennas are either thin filament or they are feathery. Adult silk moths' mouth parts are also very small and absent, resulting in them only living a few weeks without feeding. The life cycle of a silk moth starts with the female moth laying her egg. Once the female moth has laid its egg, a caterpillar or larvae are then hatched from the egg. The silkworms will then feed on mulberry leaves until it enters the pupa stage. Once the silkworm is in the pupa stage, it will then weave a net and layer around itself known as a cocoon until it's ready to hatch. Silk moth's life cycles consist of 5 steps, and within the 5 steps, the newly adult moth will then mate and relay her eggs, beginning the life cycle again. Now that we can understand the process and reproduction of a silk moth, we can now discuss the impact these insects have on the human history. The silk moths have an economic value on the history of humans by providing silk. Silk moths are the primary producers of silk. Silk moths provide the raw materials for silk production, which is a highly prized resource that was used to influence trade routes, cultural development, and it impacted our economic system, which was all done primarily through the Silk Road. The Silk Road was established because of the demand for silk from China, which was where silk originated. Humans have been using silkworms for over 5,000 years now, and it was initially developed by China, but is now spread all over countries along the Silk Road. The process of silk is obtained by the silk moth's cocoon. The silk is separated from the cocoon because of the exposure of sunlight. It is then unwinds from the cocoon, then becomes bleached, and lastly is spun into silk threads. Besides, silk moths also benefit humans with nutrition factors, health, and pollution. The history of silk moths to human civilization has been benefiting society for thousands of years and will continue to impact lives for years to come.
I will say that the silk moth is an intriguing insect and has most definitely been significant to humans. However, in comparison to the cochineal scale, it is not similar at all. Unlike the cochineal scale's high versatility in applications, the silk moth is really only good for one thing, and that is creating silk. They really only have use when it comes to making textiles. Silkworms are also starting to be outcompeted by synthetic fibers because synthetic fibers are a lot cheaper than silks are even more durable. This is unlike the cochineal scale, which is used in many household items that anyone can buy. Overall, the silk scale is being outcompeted in modern times because of synthetic fibers.
Thank you for your acknowledgement of the silk moth and of your concerns regarding the applications of it. I will say that the versatilities of the cochineal scale is great, but the silk moth may just be as versatile. Unlike what you said about the silk moth only being useful in textile, they have many applications in healthcare products, medicines, and even animal feed. Silk moths are also a good source of protein, lipids, and vitamins, allowing them to be a good source of nutrients for humans. Synthetic fabrics may also be more commonplace nowadays. They do carry more risks than silk products because synthetic fibers are essentially just another form of plastic. They take an incredibly long time to decompose and contribute to our climate's crisis. These factors allow silk production to continue to be viable and solidifies their importance for the future. You talk about how silk is being outcompeted by synthetic products, but you failed to mention how the cochineal scale products are experiencing it to a greater extent. While silk products are actually able to stay relevant due to the weakness of synthetic fabrics, cochineal scales dyes are actually being phased out. One major example is Starbucks, which is now mainly using synthetic dyes in their products. Another major issue of the cochineal scale is that there are many allergies associated with it. Mainly that, compared to the silk moth, the cochineal scale did not cause any major societal changes like the silk moth did.
Good points concerning the cochineal scale, and I will say that they are valid points. However, they are not good enough to solidify the silk moths as more impactful. You mentioned how the cochineal scales are being outcompeted by synthetic dyes. While I cannot ignore that the synthetic dyes are having an increased usage, it is still used by a majority of candy companies, and a major example being Hershey's. You also mentioned allergy risks that are associated with cochineal dyes, which is again a valid point. But with many bioproducts, there will be allergies. Many people throughout the world are allergic to silks and are unable to wear it, let alone consume those type of products. If necessary, these products are easily avoidable as long as people are reading the ingredient information. Something I cannot agree with is that the societal change of the cochineal scale compared to the silk moth. The Spaniards would essentially have a monopoly over cochineal scale in the 1500s and would transport hundreds of tons of it daily. The dyes were so heavily traded that it became one of the most valuable exports, second only to silver. Cochineal scales would be the most used dye for centuries, only losing precedence with the introduction of synthetic dyes in the 1900s. For 400 years, cochineal scales were the most important insects due to the use of its dye. The dye of the cochineal scales would hold significance to many European countries, often symbolizing strength and power. You could argue that the silk moths had a similar effect. However, they do not hold the same significance in modern history as the scale did. You mentioned the global importance of the cochineal scale and the meaning it held in society at the time. The silk moth silk was not only traded on a grander scale, but it changed Eurasians as a whole. One of the biggest things that came from the silk was the Silk Road. The road was essentially a network of trade routes that were active from the 2nd century BCE to the mid 15th century. The Silk Road not only saw the exchange of goods like silk, spices, and other precious materials, it was a huge factor in the dissemination of religion in various cultures. Civilization would exponentially grow technology due to the exchange of goods. Many towns that were along the routes would become multicultural cities heavily influenced by people of different backgrounds. Modern day religions like Buddhism, Christianity, and Islam were spread across the Eurasian continent due to the Silk Road. Had it not been for the silk moth, many of the technological advances, cultural dissemination, and modern religions we see today would not exist. Overall, the cochineal scale has been the primary source of dye, specifically fabric dyes dating back to when the indigenous people of Southern America or Central America used its fabric dye. This production dates back to the early as the 2nd century BC, when the Mayans and Aztecs would use it, showing that it has been very beneficial in human history. The dye that is created from the cochineal scale is applied to many different resources, including the coloring of cosmetics, paints, foods, textiles, and medicines, and has been used for this production for thousands of years. It is important to understand the products of creating dyes from the cochineal scales because it puts in perspective how important these insects are to humans. The dye that was produced from these insects become one of the most valuable goods and has been traded second to silver. The dye that was produced from these insects is much more sustainable to the environment than other chemicals like dye production have. Learning the benefits of the cochineal scales will show how much they truly have impacted human history.
In conclusion, the silk moth has been proven to provide applications in healthcare production while also providing good sources of proteins, lipids, and vitamins good for humans. Silk moth silk protein has been researched to provide applications in biomedical and medical devices, along with how silk moths can potentially fight off bacteria and disease in humans. The silk moths also were the producers of the Silk Road, which is a very historical event to humans all over the world. This allowed us to be able to transport and exchange goods along with the production of silk. So it is important that we study and understand silk moths because they are a vital part of human life. Silk moths are a low-cost, inexpensive insect to breed with excellent offspring. Silk moths also have homologous genes, which correspond to human genes, giving us more of a connection to the insect. Overall, silk moths are extremely important to researchers and overall human life. It is important to understand the power that silk moths have and how important they have become to human history.
And that concludes our debate.